Hello and welcome back. This is part 9 of a series covering the Hare programming language, and in this video we are going to be wrapping up this section on error handling. So we're going to start here on this section that is defining new error types, and if you scroll down a little bit, there is this section that's still left to do for handling allocation failure. I will show you how to do that. And then we are going to be testing your code doing this section here. Okay, so go ahead and scroll back up here under defining new error types and go ahead and copy and paste this into your text editor. And let's go ahead and get started. Okay, so defining new error types. Here we have a somewhat more complex sample in which we prompt the user to enter a number and then enumerate all possible error cases, such as entering something other than a number or pressing Control D to close the input file without entering anything at all. Try doing these things yourself and seeing how the program responds. We will jump over and go ahead and do that in the text editor. We can define new error types ourselves by using the error flag to prefix the type declaration. And that is right here. Okay, so here we're creating a new error type, here and here. Okay. Invalid is an error type which derives from the errors which can be returned from strcomb string to UTF-8 is what that is, strcomb stow. And unexpected EOF is a custom error based on the void type. The latter does not store any additional state other than the type itself, so it has a size of 0. We also define a tagged union containing each of these error types plus IO error and using the error flag to indicate that it is an error type. We can return our custom error from getNumber, so that's right here. And we are returning that here upon encountering IO into file, which is not ordinarily considered an error, from buffio readline, which is propagated through prompt to main. So that means here, this function prompt up to main. So here we're using error propagation. If an IO error were to occur here, it would be propagated similarly. Okay, so that's going to be through this function here, okay, through this operator here. We can use any type as an error type if we wish. Some errors are an integer or enum type containing an error code or a struct with additional information like a client IP address or a line and column number in a file, and so on. We can also provide our own string error functions which provide helpful error strings, possibly incorporating information stored in the error type. So mainly, what we're concerned with here is this section of code. Everything else in this example has already been covered so far. And so here, we use the type keyword and we just define our own type. And in order to create an error type, we're using the error flag, which prepends the type. Now you can see this is a tagged union of these two different error codes, okay, error values. Here we are just creating our own custom error type of void, and then for this type error, this is a tagged union of all of these error types plus IO error. okay? And so really this program we have to go to get number. And what's happening here is if buff.io readline returns anything other than end of file, we are propagating that through the call stack. Here we're returning unexpected end of file through this error type, okay? We are freeing it and then returning the conversion, okay? We're yielding the value, a UTF-8 encoded value, okay, to this variable and then converting it, okay? Now, if any error occurs with this, we're passing it up the stack to our prompt function here, okay? And you can see the same thing for our getNumber function, okay? We're propagating any errors up the call stack, okay? And all of our error handling is mostly happening right here in main, okay? So these are the error types that we're concerned with, and you can see the string error function, the custom one, and how this operates, okay? Now switch operates on a value, match operates on a type, okay? So the way this function works is when you match on a type, okay, you are returning a string value, and you can see that here, okay? And so we are just defining our own custom strings for these error values. Okay, so here's type invalid, okay, excuse me, sorry, I thought it was further up, that we defined here, okay? And so if we get a type invalid, we're returning the string. Now notice we're inside of a match expression, okay, and we're using the return keyword. Okay, that's because we're not yielding a captured value back to a variable here. We're actually returning this string, okay, from this function right here, okay? And if we encounter an I/O error, we're stringifying it here automatically. So every module provides a string error function, and that's basically what this is here, okay? So that's what this example is trying to show, are these custom error types that we're creating, and then also our custom-made string error function, okay? So let me see if I can find where it says try a couple of things. So it's saying try pressing Control D in the terminal to close the input file without entering anything at all. So let's go ahead and jump over here into the text editor. I have the program here. So let me go ahead and let's just run this normally. Okay, enter a positive number. Let's say 42, the answer to life, the universe, and everything. And you can see the program functions properly. Okay, now let's try and run this and enter a negative number. So we'll say, I don't know, negative 33, and you can see I expected a positive number. Let's not enter anything at all. Okay, and now let's try and pressing Control D. And you can see this is our error code that we created, okay, for the, remember, this is not normally an error, okay? This is an error that we defined, okay? So this should be relatively straightforward if you're up to speed with everything that we've done so far. We're just creating new error types and a string error function in order to stringify those errors in order to display them to the user. This should hopefully be pretty straightforward. Um, if you have any issues or you need anything further explained, please let me know down in the comments and I will try my best to help you. Okay? So now moving on to this next part, you can see handling allocation failures. This is still left to do, but I'm going to show you a couple of examples of how to handle allocation failures. Okay, so in this part, I am going to show you just a few basic cases of handling allocation failure. And if we go to the, if we go to the blog section and then look at this post right here for the release of 25.2 and scroll down a little bit, and you can see mandatory error handling in out-of-memory conditions. Okay, and this is type no mem. Okay, so if we come down a little bit, sorry, let me see if I can find this. Okay, see, mandatory error handling in out-of-memory conditions. So users are now required to handle out-of-memory errors, unifying this class of errors with the rest of Hare's conventional mandatory error handling requirements. A new primitive type, nomem, has been introduced for this purpose. Nomem is an error type and can be asserted with the error assertion operator or propagated accordingly. The built-in alloc, append, and insert features, so these are for slices here. This is the alloc. That's not a function, this is to allocate memory. Can now return a tagged union with the result type and nomem. And standard library functions, which allocate memory, can also now return nomem. Sorry, I have a little kitten in my lap, so they're just like, playing with all of my stuff and the cords and the keyboard and everything, so I'm sorry. So let me show you how to handle allocation failure. Let me give you an example with alloc, and then we'll look at an example with a standard library function. Okay, so let me just go ahead and make a basic file, and let's say I'll reach into my creative toolbox and say type chords, and we'll make this a struct. Okay, and we'll say x is an int, y is an int. Okay, now here's where we're going to call malloc. Okay, so we'll just name this ptr, and we have to use a match expression. Okay, now we'll call alloc, and inside of here is where we will allocate our struct. Okay, so if you remember the syntax, it looks just like that. That is the sort of the abbreviated form of the initialization. Okay, I think I left off a dot there. So here's the first case that we want to handle. Let's handle our allocation failure first. Okay, so the type is nomem. Okay, and then we're just going to do something like, we're just going to print allocation failure. Okay, and then the next case that we want to handle is our pointer, and it is a pointer to type coordinates, chords. Okay, and we're going to yield this back to our pointer variable here. Okay, now you could specifically annotate this, but generally Hare programs don't often use explicit type annotations. Okay, so let me just go ahead. Now we've allocated our memory. Okay, here we're handling the allocation failure, and we're just terminating our program and just printing a simple error message. Okay, and here is where we are yielding this allocated pointer back to this variable here. Okay, and so then we could do something like let's say this value is 22 and this value is 33. Okay, then we'll say pointer x, pointer y, error assertion operator, and then let's free our pointer. Okay, so let's go ahead and run this. Okay, so here's our values printed out to the terminal. Let's go ahead and look at this again. So now one thing I haven't pointed out yet is if you notice here, like if you're in, okay, like if you're coming from C, okay, this is what you would have, okay, to dereference a struct member, okay. In Hare, there is what's called automatic dereferencing for your struct types, and these are, I personally don't like this, okay. I actually really don't like this. I think, um, excuse me, I think you should have some syntax, okay? I personally wish that they would have kept just C-style syntax, right? That's very familiar. And I'll tell you why I don't like this, okay? It's because in my opinion, it violates Hare's transparency. Okay, it violates its explicitness in code, where you can look at this and you can understand what's happening here. You cannot, you would just think that this is just a normal member access, okay, that we're not actually dereferencing a pointer here, okay. I don't like it. This is probably the one feature of the language that I personally do not like, and the reason again for that is because in my opinion, it violates explicitness of code. You can't look at this and understand what's happening. You have to understand something special about the language, okay? So, so if you're wondering what's happening here, okay, if you're wondering why I'm not actually, dereferencing this like you would normally see in C, it's because it's happening under the hood implicitly, okay? So I just wanted to point that out quick. Now, so here's our no-mem error. Okay, so we're handling this here. It's very simple and straightforward. You can see all we have to do is handle the case of no-mem. Okay, and then here's our pointer, and we're just yielding it back to our variable here. Okay, so that is one example with alloc. Let's go ahead and look at an example with a standard library function. Okay, so now let's look at an example of an allocation failure using a standard library function. And if you come to this example here, thinking in terms of ownership, it's just something I thought of really quick that I can use to show you how to handle allocation failures with a standard library function. And so let's jump over into the text editor and let's just copy this in here. Okay. Now, if you're wondering what this is, this Hare make I'm using, it's just a program written in Hare that I wrote in order to bootstrap a program and put you in your text editor. That is, it's right here, okay? And it's just a very simple program. I plan on, it's just something I kind of wrote in order to learn the language a little bit. So we're basically just passing in a file, opening that, and then we are using these functions in the exec module in order to actually open up and put us in our text editor. Okay, so um, that's that's all that is. It's just a simple Hare program that I wrote. Okay, so the example that we're concerned with here is this right here, okay? Um, this here, and allocates memory. Okay, let me remove this. Okay, so now let me go ahead and just redo this here so that I'm not inserting stuff all around the code that might be confusing. Okay, passing in our file, and here's our match expression. Okay, so now we can delete this line. Okay, so we are matching against our IO drain function. Okay, now let's go ahead and pull that up, and you can see it returns a byte slice on success, or on error it can return an IO error. So you can see that one of the errors under IO error is no mem, okay, because it will fail to allocate memory. And that is what we are going to explicitly handle here. So it's the same thing. We would say case no mem, and let's just do the same thing. We'll say allocation failure. Okay, now for our success case, this is a oops, this is a byte slice. Okay, and we're yielding it back to our buffer variable here. Okay, so you can see, and what this program does is you can see it opens up our main file, okay, and prints it out to the console. Okay, so this is really what we're concerned about here, is this no mem case that we're handling. I do have to, looks like I forgot to handle any other IO error case, so let's do that. So now we have full and proper error handling with this function. Okay, and this is the case that we're concerned about here, is no mem. Now you can see that under the hood, some of these functions, you can see the caller must free the return value. Okay, that was the whole point of this little exercise here, was to highlight this. Okay, and under the hood, this is allocating memory, and I personally, just like the struct member dereference, there's nothing explicitly in your code showing that that's happening. I personally think it'd be great if there were some type of operator here like that. That's just, one example of what you could do with this function in order to, for any standard library function that allocates memory dynamically. Now this is very common in C, okay? But in Zig, for example, this problem doesn't exist. One of the very explicit design goals of Zig is to have no implicit memory allocations. Okay, these can cause problems. This is very common in C. If you're coming from C, you'll see this quite a bit with, like the like glibc, or even muscle, I think, too. So I don't know. It's just something I think would be great, right? Because I think, explicitness in code is really what I prefer. And when you have things happening sort of behind your back, under the hood, that you can't see and reason about just from looking at the code, I just think it adds to kind of the cognitive load. So anyways, the point is, this is allocating memory dynamically. That might not work, okay, and that right here you can see that we have the free. We're not concerned about that right now. We're concerned about this no-mem error. So this is basically what it looks like, and this is how you would specifically handle a, a allocation failure with a standard library function. Okay, so hopefully that's clear. If you do have any questions about this, please put them in the comments, and I will certainly try my best to help you out. Okay, so let's go ahead and move on to this final portion under memory, excuse me, under error handling, which is testing your code. Okay, so now let's look at this part. It's called testing your code, and this right here is what we're concerned about. Okay, this is with the at sign. This is called an attribute. Okay, so Hare has first class support for tests via the test attribute on functions. You can run the test for this sample program by running Hare test in the directory where this file is present. Our simple sample here is a bubble sort implementation. You may already know that this is not a very good sort algorithm. You will likely wish to use the standard library sort module in real-world code. Note that this code does not have a main function. Hare run will not work here. You can test code which is not strictly speaking a program, in quotes, such as libraries written in Hare. And that's mainly what this feature is for, is to test your modules, okay? Also take note of the use of the assert built in. Now we already covered that. If you're not familiar with that, please look a few videos before. I did a video on assertions. Given a condition, a boolean, if the condition is false, the program is stopped and the message is printed. You can also skip the message if you don't need to be specific. The file name and line number will be printed, and you can generally figure out what went wrong regardless. So what's happening here is this is a module. Okay, there's no main function here. Okay, this would be like this is like a third-party module, or you can think of this as like a utility file that you're importing into your main translation unit. Okay, and this is the function that we're testing. Okay, we're testing this sort function right here. Okay, now what bubble sort does is it's a very simple sorting algorithm. I'm not going to get into detail with what it does exactly. But it's a very simple sorting algorithm that's basically guaranteed to sort your collection within the same number of passes as elements that exist within it. Okay, um, and again, I don't want to get too hung up on sort itself, because that's not what we're actually testing here. What we're testing this function, and we're worried about this test attribute. Okay. Um, Now, if you notice, this function is named sort, okay? And to me, in my mind, when I first looked at this and I was trying to figure out Hare, this is confusing to me, that this happens to be named the same thing as our uh, our primary function that we're trying to test. So in my mind, that was always confusing, because you have sort here, and then we're calling sort inside of itself. Of course, you can have a recursive function, but that's not what this is, okay? Um, in any case, though, this is the function we're testing, and this is where we're testing it. We could name this something different, okay? We could name this test sort or sort test, something like that, but if you wanted to give your test functions, if you wanted to prepend them with test, that would probably be a good thing to do. Now I don't want us to get hung up on this algorithm in here, okay? So I want us to focus on this. So I'm not going to run this program right now. Please feel free to do so if you would like. Copy and paste this in your text editor. If you're not familiar with basic algorithms, there's a ton of videos and courses you can look at, or just type in bubble sort and it'll show you the basics what a bubble sort algorithm is, okay? But let's go ahead and jump over into the text editor here, okay? And I can just show you a basic example of how to use this test attribute on for your modules, okay? Now, again, we're not running this on our main translation unit, so there's no executable main function. So let's just call this print, okay, and we're going to be printing something out. And let's make a function called print name, okay, and we have an input of type string, and it returns void, okay, and then let's just say printing name, okay, here we have and then we pass our input in, okay, so here's our function, just very straightforward and simple. We're just passing in a string to this function, and it's plugging it in right here and printing it. So let's say this is well, it is in its own file, but let's say we wanted to import this into our our main file. So here is where we would put our test attribute, okay? And it's the @ sign and then test, and this is the test itself, okay? So let's go ahead and make a function, and let's just call it, we'll call it test print, okay? And you can see this looks like any other sort of regular function, okay? This is the syntax for it. You have to actually define it with the fn keyword. And again, you can name this whatever you want. That doesn't matter, okay? And let's make a string, okay? And we're going to pass this in. Now here's where we're going to call our print name function, okay? So let's call print name, and let's pass in our name, okay? And this is basically just this function in action. There's nothing else really to do here, okay? But this is going to test this function here that we're calling right here, okay? Now, once you have whatever function that you want to make, and then the test attribute, the test function to test it, you'll come back into the terminal here, and you're just going to run Hare test. You don't need to pass in anything else. And you can see running one of one test, test print, that's the function that we're using to test our function, pass, okay? One passed, zero failed, okay? So let's look at, let's say, let's test two different functions. So we'll make an add function, and we'll say aint, bint, and it returns an integer, okay? And then we'll also test multiply, and it might not always return an integer if it's a anyways. Okay, so we'll just say returns an integer, and we'll say return a plus b. Okay, so for our multiply function, we'll say return a times b. Okay. I think it will always return an integer if we're passing in an integer. So here's where we'll create our test attribute for, and we'll say test add, okay? It doesn't have to return anything, it's just testing, okay? Now, let's create some values. We'll say a, and let's make this 22, and we'll have b. I know, really creative, right? Really, I'm just trying to show you the basics of this without really kind of overwhelming you. Okay, now here's where we're going to call our function, our add function, and we'll pass an AB, okay? And then, you know what, let's capture this in a value, okay? And then let's print that here, okay? Now I have to import the FMT module. Okay, now let's create a test function for our multiply function. So we use the test attribute, and we'll say test multiply returns void, and basically the same thing. We're just going to create a couple of values. And then we're going to call that here. We'll say multiply and then pass in A and B. Okay. And that's really all there is to it. Okay. So you can see we have our function that we're creating here and here. And we're testing them here within the same module. Okay. So let me go ahead and save this. And again, all you have to do is run Hare test. And you can see that both of these functions passed. Now, obviously, these are extremely trivial examples. But I'm just trying to show you how to use this test attribute and the basics of it in order to test your functions for your modules that you're importing and using. Okay. So that is the test attribute. That's testing your code. Okay. And that should wrap up the error handling part, which was kind of lengthy. I think this has probably been the longest portion of this tutorial so far. And as you can see, the next part is going to be control flow. Okay, so we still have to do control flow, types and depth. That's probably going to be the next longest part. Slices, functions, and then modules. Okay, and then, you know, once I wrap up this series, you're hopefully going to have a really good grasp on the fundamentals of Hare, enough for you to start building some hopefully non-trivial programs. Okay, so that is going to wrap up error handling. Um, Thank you so much. Happy 2026. I want to thank all my subscribers and any new subscribers, and just anyone who finds this series helpful. So thank you very much for watching. I really do appreciate it, and I will see you in the next video. Thank you so much. Have a nice day.